If you look around the world right now, we're constantly on this tightrope walk between innovation and, well, necessity.
Hmm.
And when a really serious housing shortage hits, and it has, I mean, in a huge way, in places like Jamaica,
Absolutely.
people start looking for, these dramatic solutions.
Right.
And that's where the container home comes in. It's become this incredibly powerful and really polarizing idea.
It is the ultimate tension point, isn't it? Because on one hand, it promises speed, it promises affordability.
Right.
But on the other, like you said, it just splits the conversation right down the middle.
Yeah.
Either you see them as the future of low-cost housing, or you're terrified they're a shortcut.
Sure.
A shortcut that's going to lead to the next generation of, frankly, unlivable slums.
And once the debate is framed that way, it's not useful anymore. It's just emotion.
It's just noise.
That's exactly why we're doing this deep dive. We've pulled our analysis from an excellent professional critique, one published recently in the Jamaica Homes Journal. It really sharpens some of the initial commentary from a chartered builder, Dean Jones. And our mission today is just to slow the whole conversation down and separate the feeling from from the engineering.
That source material is so crucial because it forces everyone to just take a strategic pause.
Right.
We aren't here today to argue if container homes work.
No.
The real question is under what conditions they work,
Mm.
especially when you factor in the very specific environmental and governance realities of a place like Jamaica.
Which brings us to the core question of this whole thing. It's a fundamental one. How can we build housing affordably and safely and do it at scale without creating a massive systemic crisis 15 years from now?
Because that's what so often happens.
Yeah.
Urgency just overwhelms diligence.
Exactly.
That is the danger. And the very first step toward thinking clearly about this, which the source material does just brilliantly, is redefining what we're even talking about.
Okay, let's get into that. The critique, right away, it yanks us out of that false binary, the whole silver bullet versus dangerous shortcut thing.
Yeah.
It makes the point that if you treat a highly technical, really high-stakes discussion as if it's purely emotional, you just stop asking the right questions, the tough questions about material science and process.
You lose all the technical ground.
Yeah.
And we have to deliver the crucial nugget from the article right at the top, because it changes everything.
Okay, what is it?
A standard shipping container is not housing.
Right.
It's not a dwelling. Fundamentally, it is a structural component.
And component, that.
Yeah.
Wow, that is a powerful distinction.
It is.
Because the second you start treating it as just a component, you stop obsessing over the box itself, which was designed for cargo, not people, and your focus immediately shifts to the necessary system that has to be built around that component. You're talking about turning a hardened steel crate into something that's actually livable in the tropics.
And that system is incredibly complex. The critique points out that the steel box itself is almost irrelevant compared to the specific technical elements you have to integrate
To make it work.
to make it resilient. You mentioned the tropics. That steel box, if it isn't properly treated and insulated, becomes a massive heat trap, a condensation generator.
I wonder if that's the core of the problem, that distinction. Component versus housing. People see the cheap box and they forget about all the expensive necessities that have to go with it.
That is exactly where the system breaks down.
Yeah.
We're talking about at least 4 non-negotiable requirements here. Treatment, insulation, ventilation, and anchoring.
Okay.
If you skip the proper marine-grade treatment for rust, that container, which is constantly exposed to salt air and humidity, it will start to rust out. Maybe in 5 years, maybe 10.
Guy.
That if you don't use proper external cladding and high-spec insulation, and I mean non-flammable, serious insulation, you get what's called severe thermal bridging.
Which means the inside temperature is basically the same as the outside temperature.
Exactly. It becomes uninhabitable, and it forces you to run expensive air conditioning constantly.
Which totally defeats the entire point of affordable housing if your utility bills are through the roof.
Precisely. And in a humid place, bad ventilation plus that thermal bridging means one thing: condensation.
So moisture everywhere.
Massive amounts. And condensation leads to mold, which causes immediate health problems, and on top of that, it degrades the building materials even faster. The problem isn't the steel. It's the lack of the system to make that steel work.
And that brings us right into the next piece of this, because you can't talk about design without talking about the relentless environmental constraints in Jamaica.
No, you can't.
These aren't abstract, worst-case scenarios. They are daily realities that any housing solution simply has to withstand.
They're the ultimate test.
So,
I mean, just think about the list of what a new home in Jamaica has to survive. You've got
Mm.
persistent high heat, extreme humidity,
Right.
constant salt air corrosion, especially along the coasts. Then you have the annual threat of severe hurricanes, and this one is critical, significant seismic activity.
Wow.
That is a brutal set of requirements for any material, concrete, timber, or steel.
When you list them out like that, it just makes the technical challenge so clear. If you pick a material, any material, and you ignore those factors, failure is just. It's guaranteed.
It's absolutely guaranteed. Let's just take the salt air. Containers are built to resist corrosion for ocean travel, sure.
Yeah.
But the moment you cut them, you weld them, you expose new surfaces, those protective coatings are compromised. If the builder doesn't retreat those new surfaces to the highest standard, the structural integrity is at risk from day one.
And then there's the hurricane risk.
The hurricane risk. A poorly anchored, lightweight container home becomes a missile in a Category 3 storm. It's a danger to everyone around it.
So it's not the material that fails, it's the engineering for the conditions. The key takeaway here is context. Building a container home in, say, arid Arizona is a totally different engineering challenge than building one facing the Caribbean Sea.
It's night and day. And, this isn't the first time we've seen this kind of thing, where innovation gets tripped up by expediency.
Yeah.
The source draws this fascinating and really relevant parallel to post-war prefabrication schemes, specifically the temporary housing they built in Britain after the war, and some similar mass housing schemes right there in Jamaica.
Tell me more about that. What was the lesson from those failures?
The lesson is so consistent across the decades. The failures almost never come from the innovation itself, whether it was prefabricated panels in the 1940s or steel boxes today.
Okay.
They come from rushed implementation, political expediency, and a willingness to just lower standards to hit some arbitrary cost target.
So history is full of examples.
Jamaica's own history has schemes that were built fast and cheap, only to face massive long-term costs, inadequate foundations, poor water runoff, and materials that they couldn't stand up to the tropical climate for more than a decade. They became expensive to fix and a burden on the people living there.
The history is basically screaming at us. Don't let urgency become an excuse for poor quality. Which leads us to the real core of the issue, the systemic risk. This is where the critique really pushed beyond the original article. The issue isn't really the design quality, it's the application of standards. And that means we have to talk about governance and enforcement.
This is the real aha moment for you, the listener. It's the single most critical point the professional critique makes. Just saying, oh, container homes work if they're done properly is, well, it's a true statement.
Yeah.
But it's dangerously incomplete, especially in a place with high rates of informal construction.
Why is it incomplete, though? You'd think that a simple, known box geometry would be easier to inspect than some complex, custom-built house.
That's a good question, but the complexity is hidden. The source points out that the systemic risks are rooted in weak oversight and inconsistent inspections. A huge percentage of builds happen informally outside of any official pathways.
Okay, I see.
So now, into that already strained system, you introduce a structure that needs specialized welding, non-standard material treatments, and very specific insulation solutions. Things inspectors need special training to even verify. You just magnify the entire risk profile.
So the regulator is already struggling to enforce known standards for traditional building. Now you're adding a whole new set of complex, nuanced standards for these hybrid structures. The chance of failure in that enforcement chain just goes up exponentially.
Exactly. And the pressure to cut costs, it's immense. If a builder skips the mandatory closed-cell foam insulation and uses something cheaper, who's going to catch that?
Right.
If they use cheap window glass that can't handle the wind load in a hurricane zone, who stops them? The problem isn't the steel box. It's the lack of process, certification, and accountability.
So the immediate practical danger here is that because of this vacuum in governance, people will just build bad container homes over and over again at scale simply because they're cheap up front.
And those will become tomorrow's failures. This requires a targeted solution. The source insists that what's needed right now isn't better PR for container homes.
No.
It's the establishment of clear national guidelines. We need recognized certification pathways and really rigorous inspection protocols that are specific to these structures.
That means training inspectors.
It means training inspectors on thermal bridging, on specialized welding stress points, on the mandated material treatments, all of it.
If the systemic risk is failure, then the systemic solution has to be certification. Without it, you are basically just licensing people to build a crisis.
And if we connect this all to the bigger picture, we step out of just construction and we move into planning and real estate. The article touches on this subtle but deeply important dimension, land use.
That's right, because these homes are often sold with this idea of mobility, like they're temporary. But the source is really clear on this. In the Caribbean context, housing becomes permanent, legally, socially, emotionally, the second it touches the ground.
A critical distinction. The moment that container is placed, it starts having a ripple effect. It affects neighboring property values, it puts unexpected loads on infrastructure, water, sewage, utilities, and it challenges all the existing drainage and planning norms.
So a container home is never really an island, it's part of the community fabric. What does that actually mean for the homeowner who just wanted a stable place to live?
It shifts the entire conversation.
Mm-hmm.
The debate stops being purely about structural engineering.
And becomes what?
It becomes a conversation about planning, zoning, and real estate. The long-term factors, the things that actually guarantee stability for a family matter, so much more than the initial cost of the box.
You're talking about things like zoning classification, like can this structure even legally exist where it's been put?
Exactly. And then valuation. How is an appraiser going to value this unconventional structure? If it doesn't meet clear national standards, the valuation plummets.
Which means a bank is not going to give you a mortgage for it.
Highly unlikely. And if a bank won't finance it, it's not a sustainable transferable asset. It locks the owner out of the entire financial system.
And insurance. I can only imagine. A Category 4 hurricane hits, the structure was non-standard, poorly inspected.
The insurance company will simply deny the claim, and the homeowner is left with absolutely nothing.
That is the real consequence of poor governance.
That's it. If you can't insure it, if you can't finance it, if you can't transfer it easily in the formal real estate market, it's not a viable long-term housing solution, no matter how cheap the original box was. The affordability crisis is only solved if the solution creates lasting, secure assets.
This whole deep dive really shows why we have to elevate the conversation. The source material, from the initial article to the critique, it succeeds because it insists on one thing. Materials do not create national crises. Decisions do. The choice to bypass rigorous standards, the choice to put speed over durability, those are the problems.
And the final conclusion from the source is the one we really have to embrace. Standards are everything. If your standard is poor, your building will fail. It doesn't matter if you use traditional block and seal or an innovative steel box component.
The engineering is solvable?
The engineering challenge is interesting and completely solvable. The governance challenge. That's the real costly barrier.
Which leaves us with a final provocative thought for you to think about. If the real hurdle for housing innovation isn't the material, but the lack of an enforceable certified process, then maybe we need to look beyond just building codes.
Go on.
What other national system, one that's designed for high-risk, high-consequence environments, I'm thinking of systems that certify engineers or medical devices or large-scale civil infrastructure, could offer a blueprint? A blueprint for the kind of rigorous mandatory certification we need for these new building types. That level of oversight applied to construction might just be the real next step in housing stability.